Okay. Okay, maybe a month ago, I wrote a blog post for Databricks called Apache Spark and the Typesafe Reactive Platform, a match made in heaven. So first, what is Typesafe? Well, Typesafe is actually the company that builds Scala, which is the basis for the implementation of Spark. So we have an unusual relationship compared to other vendors with Spark. We're kind of the tool that makes it possible. I'm Dean Wampler. Here's my spam addresses if you need to spam me. Some other things we do is we build a middleware framework called Akka, which is an actor-based, highly scalable, highly resilient model. If you know Erlang, it's basically the same highly scalable, reliable model. I guess I'm saying that several times. And Play is a web framework that we also build for building highly interactive applications with typical web interfaces. One of the things I'm going to demonstrate is a template that isn't actually yet on Activator, but I've already got one up here that I'm showing, which is a workshop. It's a self-study tutorial on Spark. The Typesafe Activator is a community-driven platform for people to build and post sample applications using tool A, tool B, API this, API that, et cetera. And so we're starting to see people contribute Spark examples. So if you want to get started with Spark, check out the Spark workshop on typesafe.com/activator. And the demo that I'm going to do, I'll post probably next week when it sucks less. So, excuse me. I started consulting in the Hadoop world about 4 years ago, and immediately was obvious to me that MapReduce needed to go. We needed more of a functional programming model. We needed an intuitive API. We needed languages that embraced the natural data flow model of functional programming. This is a slide of a talk I did, 3 years ago about this, 2 years. And then recently I did a talk where I was sort of celebrating the fact that Spark had been embraced as the next generation. Because we needed to get away from crap like this horrible MapReduce API, to glorious, beautiful stuff like this, which is the Spark API. Thank you very much. Yes, definitely. So, and this particular example is taken from that Spark presentation. It took me like half an hour to write the Spark version. It took like a day to write the MapReduce version. Anyway. Now, you've all seen pictures like this already. Spark on top of Mesos, Yarn, databases, et cetera. Well, if you peel the onion a little bit and look inside Spark, once again, you have Scala at the bottom. There's a little bit of Akka in there already. And then there's other APIs, of course, written in Scala and Java. One of the ways that Typesafe and Databricks is working with the Spark community is to actually improve Scala, to make it a better language for writing these kind of distributed systems. For example, one of our engineers is spending the summer with the Spark team working on improving the ability of sending anonymous functions over a network. And that actually is a hard thing to do well in JVM systems. And we're also extending libraries. For example, you may have heard the buzzword reactive programming and another buzzword, reactive streams. Reactive streams are sort of like the regular data streams you know and love, but they embrace something that's extremely important for resiliency, which is back pressure. You don't want to just keep shoving data to a receiver if the receiver can't take it fast enough. So you need the notion of back pressure to control that rate flow. And this is something that may show up in Spark later. We don't know, but I'm going to actually show a little demo that uses this. And the demo is sort of along this model of an Internet of Things deployment, which would be a bunch of devices, and I just arbitrarily picked Fitbit images. I could have picked Jawbone or anything else. But what do all of these devices do in common? Well, they send telemetry data, some sort of information back to central services. They may get feedback, control messages, do this, do that, shut yourself down, reboot, upload new firmware or whatever. And what we think people should be doing is actually building this central management middleware on top of something like Akka that is extremely good at resilient scalability and very good at handling just a lot of stuff coming in at once and can give you the event responsiveness you need for certain SLA requirements. You might build a management console in the Play UI. There's certainly a lot of ways you could do that. And then the way Spark comes into the picture is the Spark streaming is a beautiful model for streaming data and doing online analytics. I've got a machine learning model. I need to update it in real time. I've got data coming in from the field. I need to update my model of what's actually in the field, whether it's maps of the world or things like that. And we think that Spark plus Akka plus Play is a really beautiful combination of tools, one programming language, either Java or Scala, and you can do all kinds of stuff with it for not only Internet of Things, but many other kinds of applications. So let me show you a brief demo then, and to make this work, I need to go into mirror my display. Let's do that. Should have done this before. There we go. Now you saw you don't want to see my email. You saw some really impressive UIs a minute ago. I'm going to show you the ultimate graphical visualization tool, which is Z-Shell. So I'm going to, yeah, I'm kicking it old school here. Oh my gosh, there we go, thank you. Everything's got to crash. So anyway, what's going on? I started an Akka server in the middle. It's going to receive data from clients over these reactive streams. And now you're seeing my last slide. That's up. So now I'm going to start the Spark streaming process, which is going to accept stream data, and it's going to do some analytics that I'll describe in a second. Now they're connected, so let's run. Actually, I think it's already, there we go. Now we're going to actually load some data through the system from a client that will get processed by Spark. This is actually flight data from 2008, when planes took off, what airports they flew between, when they were late, and so forth. And it's a simple example that just basically sums up the number of flights between pairs of airports. So it's extremely sophisticated. You can see the visualization is incredible. But it just illustrates the point that you can very easily glue together some non-trivial components to build things that could in principle scale to really large data sets, high volume, high resiliency, and so forth. So to wrap up, let's find that presentation again. There it is. So here's my cat. I'm glad to be done. We're going to be out in the lunch area if you want to talk to us a little bit more about Typesafe. But anyway, thank you very much.
Have a seat. Sorry, I don't have fancy accommodations. Same chairs. Man, that's all I have. So I'm curious, from a Typesafe perspective, obviously you guys have always been behind Scala and so forth. When you see the Spark community, see what it's building, kind of what comes to mind? What surprises you? What was natural for you guys and so forth?
Yeah, I'll start with the natural stuff. Obviously, as I've said, I've been looking for this to sort of take over the big data world for a while, and so it's exciting to be here and see what's happening because it is such an intuitive model for a very wide variety of data analytics that you might do. Maybe the surprise would be just the variety of things people are doing, like the neuroscience discussion we had this morning was just fascinating. Yeah. But it all comes back to the central principle that I believe is true about Spark, that when you get the abstractions right, when you get the core tooling right, the world is your oyster. You can do anything, and we're just seeing that at this conference, I think.
Yeah. And then if people ask, right, I mean, obviously Spark was written in Scala. Scala API was one of the first ones, but now we see, well, okay, Python is added. We heard this morning Spark R. Kind of, how do you guys think of, is it just a matter of what are you comfortable with? Is there times where you say one API might be more expressive than other ones, or from a language perspective? Like as people are thinking about building on top of Spark?
Right, I think you have to be realistic about what the world can do. Data scientists typically are working in Python and R. They're going to be more comfortable with that. The beauty of Spark is that it lets you use any of these APIs or languages, and I think that's been really smart to embrace those different options. And so, a typical mature data team will have engineers that are writing sort of the oddball applications to do ETL and other things. The data analysts will be taking the more clean data and doing their analytics. So it's a great combination. The best tool for the job is our view.
And so maybe an odd question, but you're obviously very familiar. You've built a ton of stuff on top of Spark. Where are there areas where you would still say, okay, this is still a little bit painful. I'd like to see this get easier and so forth. So we've moved away. Where's the next slide where you have, here's what MapReduce, here's Spark, and now, a year later, what's the slide that you put up that this is even easier than it was before?
Well, I have to say, one of the things I've been worried about is data visualization and interacting with Spark, but also presenting data. And I think you guys are kind of nailing it, to be honest, with the stuff you rolled out yesterday. Not to suck up to you too much.
I didn't pay him, I promise.
Yeah, you can pay me later. Yeah. No, I think that was the big one. Of course, there's always going to be challenges with integration. There's going to be oddball scenarios where things go wrong when people really put it on 1 million machines or whatever. But I think you guys will easily nail those things too.
Okay. And so then I guess the last thing is, would you give, let's say, a developer starting with Spark today, like are there kind of, based on your experiences, any 2 or 3, here's the main pieces of advice to keep in mind as you're building it to make your life much easier?
Yeah, I think, well, a couple of things. One is that Scala has some rough edges, some complex edges, but Spark hides those very well. I would focus on just learning those core operations that you can do with RDDs, practice some examples like the workshop I have, and then build out from there. And I think it actually is a pretty nice experience for learning as well as actually getting real work done.
Okay, fantastic.
All right,
always
you.
a pleasure. Thank you. Okay. I know we are running a couple minutes late, so just bear with me. I promise I know most people are probably already streaming the US game, so want to just invite kind of our last but certainly not least guest, Michael and Christopher from Databricks. So thanks.